So scholars, now that we understand average speed and instantaneous speed, we could start to discuss the meaning of this new word, limit. So how do we find the limit of a function? How do we find the limit of a set of values? So if you just pause the video for a moment and read at the beginning of chapter 2 in your textbook, the front material before the chapter. All right, so you got a chance to see in your reading. We can investigate limits using substitution, so plugging in a value. We can investigate using graphs to see the behavior of the graph near a certain value, and we can also use tables of values. You might remember that in the video from earlier, we looked at a table of values for different values of h that we plugged in as they got smaller and smaller, so we can use those two to investigate limits. And the one we haven't, we did try yet, that's using algebra. So remember when we FOILed out that expression that had the h in it, and then we were able to cancel h, we could use algebra to find limit. So a key idea that I sometimes trip students up, so I want to be really certain that you get a chance to know, a limit is always a y value, an output value. It's never an input value, so it's not an x value, it's not a value of the domain, it's always a range value. So keep in mind as we talk about limits. And the whole reason we talk about limits is so that we can talk about continuity in section 2.3, because continuity is required for all of calculus to work. So we have to understand continuity before we can start to talk about what calculus actually is. So to start to understand what a limit is, we want to remember what we did in class today. We started with computing average speed, so taking the distance traveled and dividing it by time elapsed to find average speed. And we used that to then say, well, what if I want to find instantaneous speed, speed at one exact moment in time? I could use that same formula, that idea of dividing distance traveled divided by time elapsed. And if I let the time elapsed become so small that the difference between the two times is practically zero, remember I could make a table, let h get smaller and smaller and smaller, then I could use that to try to understand what instantaneous velocity is. So what I have here is that same work from today. If I have two time values, time t equals 2 and time t equals 2 plus a teeny tiny bit more, I'm going to call that teeny tiny bit h. And I'm going to do the algebra that we did in class. So I plugged in 2 plus h here I plugged in 2 plus h for time, and I'm going to FOIL that out, and I can use algebra to cancel the 64s. And now I'm here, and I see that my problem before was that I have an h in the denominator, and if I want to think of h as 0, I can't have a 0 in the denominator. But now notice I'm able to cancel out that h, and I'm left with this expression down here, 64 plus 16h. But if my whole idea is to think of h as something really, really close to 0, and in fact I try plugging in numbers close to 0 and then closer and closer and closer to 0, finally, since I don't have the 0 in the denominator anymore, I can use 0 for h, and this term here cancels out, and that's how I got that 64 feet per second earlier today. So it turns out this process is actually a limit process, we just haven't used the words for it yet. So watch this same problem. I'm going to move to the next slide, I'm going to use some new notation with it. So here you see for the first time, at least for the first time with me, maybe you've seen limit notation before, is notation for a limit. This limit notation, which I'll circle, is just an algebra way, a math's way, an agreed upon mathematician's way of saying we're going to pretend h is a really small number and let it get smaller and smaller and smaller, and so it's so close to 0 that it's practically 0 and we can just plug 0 in. So let me read for you here. I've written on the side, we would say that the limit as h approaches 0 of 64 plus 16h, we would say is 64. So that's how we read that notation. The limit as h approaches 0 of 64 plus 16h. And we're going to talk more about how to evaluate limits.